Okay, so if you recall from geometry, trig functions can be used to find missing side lengths and angle measures of right triangles. You guys remember that, right?
Yeah.
Okay, so you do it the same way that you did back in geometry here, okay? You identify what side you're given, figure out the trig ratio to use, and you solve it, okay? So you got a 60-degree angle. X, is that your opposite side, adjacent or hypotenuse? Opposite. What about 20? So what trig ratio at a sine, cosine, tangent, sine has opposite and hypotenuse with it? So you set up your ratio. The sine of your angle, which is 60 degrees, equals what over what? X over 20. Your opposite side over your hypotenuse. And then to find x, you need to solve. How do you solve? Multiply both sides by 20. So you'll have 20 sine 60 equals x. And that's what you type into your calculator. Now, if you do not have a calculator that allows you to do trig functions, you get me down to this point right here. Because then that way I know this is what you would type into the calculator. So, calculator's out. We're typing this in. It's not 60 times 20, it's 20 times the sine of 60 degrees. Yeah, go ahead. Okay, now we're rounding to the nearest 10. 17.3. Okay, now one thing you gotta be careful of, okay? I'm dealing with degrees here. So I need to make sure that my calculator is in degree mode. So everybody go to their mode real fast. If it's radian, you'll get a completely different answer. So make sure that you are in degree mode. Everybody knows how to do that, right? Okay? You go right up here to mode. Make sure that degree is highlighted. So you go over, click enter. That's how you make sure it's highlighted. So 20, sine, 60. Everyone get 17.3? There you go. Okay? So again, you get me down to this point if you don't have a calculator. But if you do, you give me 17.3. That's the value of x. Alright? Let's do it again. Over here, I'm given a 25-degree angle. What is x?
Hypotenuse.
It's the hypotenuse. Remember, it's across from that 90-degree angle. What is the 8? Opposite. What trig ratio am I using? Sine. So I set it up as sine what? 25 equals, careful, 8 over x. It's your opposite side over your hypotenuse. Now this is different from the first one. Why is it different? X is on the bottom. So I'm not going to end up multiplying my number and then my sign together. I'm going to end up doing something different. Well, we could use cosine of that other angle, but heaven forbid we rush through it and we end up getting the wrong angle and then we have no chance of getting the problem right. So, how do I solve for x? What do I do here? Multiply by x to get it out of the denominator. You'll get x sine 25 equals 8. Then what do? And I divide by sine 25. So when x is on the bottom, I'm actually going to divide my number and my trig function. But if it's on the top, I'm going to multiply like in number 1. So I type that into my calculator. 18.9, can I get confirmation? Sweet. Do you guys remember this? Now remember, you can also use your trig ratios to find angles, okay? Exactly. This would be when you use the inverse features of your calculator, okay? That you are going to have to draw in these triangles. They're not a part of your notes, okay? And of course, we don't want to make any assumptions here. These are right triangles. Set it up the same way. We're basing my sides off of the angle that I'm given. So here's my angle. 26 is what? Your opposite side. 11 is your adjacent. What trig ratio has opposite and adjacent? So you set it up. Tangent of what? Hold on, don't give me steps. Careful. Theta is always tangent of your angle. So in this case, our angle is theta. That's what I'm looking for. What's the ratio? 26 over 11, opposite over adjacent. Now, to get rid of the tangent that's attached to the theta, because I'm looking for the angle, this is when you do the inverse of that trig function. That -1 and the exponent, that should look familiar. Y'all remember when we did -1 and the exponent? That's when we did inverses. Lesson 6, I believe. Okay? We do the inverse of these trig functions. How do I get that inverse? You gotta press the second button. So I'm gonna go to second, then tangent, and I'm gonna type in my fraction, 26 over 11. Close it off. Did everyone get 67? There you go. And I'm rounding to the nearest degree, so it's going to be just 67. Yep. You can put the degree somewhere, not. I'm not going to penalize you. Sure can. All right, you guys try the next one. Try the next one. Is my opposite side. It is across from that theta, an acute angle. What is 16? Hypotenuse is across from my 90-degree angle, so I'm going to use what here? Sine. So it's going to be sine of theta equals 14 over 16. To solve for theta, I have to do what? The inverse of sine. So I press the second button, I press the sine button, and I get to the nearest degree. 61? Yes? Good stuff. Coming back? You remember this? Okay? Biggest thing, just make sure that you label your sides, guys. Make sure that you label your sides to help you. Now this can be used with your application type problems. Angles of elevation and depression. I don't know if you guys remember this from geometry. But remember, your angles of depression and elevation always come from some horizontal line. Okay, so I have two different pictures for you. Okay? So, I mean, this is for you. You can draw these in if you like, you don't have to, okay? But basically, these are two different representations of your angles of depression and elevation. Say you have a person standing at the top of a building, okay? So you have a building right here, okay? And they have an angle of depression to a car on the ground. Well, it comes from some horizontal line, then going down. That is the angle of depression. It always comes from some horizontal line to whatever they're looking at, okay? Angle of elevation is the same thing. Say you have a car on the road at the base of a building, and the driver sees somebody standing at the top of the building at an angle of elevation. It comes from some horizontal line going up to represent that angle of elevation. Well, you would definitely use this when you're dealing with right triangle trigonometry problems, word problems, okay? This should look familiar when you have two parallel lines cut by transversal, when you have angles on opposite sides of the transversal. Alternate interior angles are congruent. All angles of elevation and depression are congruent, okay? Here's another picture, okay? You have a person who's standing straight, okay? And right now, I'm looking straight ahead at the door, okay? But oh no, I see a cockroach crawling on the ground, so I have an angle of depression because where I was originally looking has now been averted down, okay? Here's the door. There's the roach, okay? That angle of depression comes from that horizontal line of me looking straight at the door, okay? Or, oh yeah, you're right. I am going to run this way, so, okay? Or I can be looking at the door and notice, hey, there's a water leak at the top of the ceiling, okay? I'm going up, angle of elevation, okay? Have I killed this bird?
Ceiling.
Have I killed this horse enough? Beat a dead horse? Yes?
No, you haven't
Phone?
beaten enough.
Okay. So there's some more problems.
I think I know what she's not think with you too.
Why?
Oh man.
If you start your metaphor.
You know, be whatever. Yeah, I know what I'm talking about.
The Leaning Tower of Pisa in Italy is about 55 meters tall and is leaning, so it is only about 55 meters above the ground. And what angle is the tower leaning? Okay? You have no picture here, so what might help you? Draw it. Okay? You have a leaning tower of Pisa. Now realize that I'm not an art teacher either. Okay? So however the tower looks like, there is the leaning tower.
That's rough.
Okay? Now clearly the tower is
55.9 meters tall.
on the ground. It's about to fall. Is 55.9
.9.
meters. Okay, so I already know that that's going to be 55.9 meters.
Wait, it's 59.9 meters straight up? Or is it just the tallest tower?
It's the tallest tower, so no matter if the tower is standing straight up or if it's leaning, the tower's length is going to be 55.9. Now it's leaning so that it's only 55 meters above the ground.
So that would be like.
That means it's back.
Where would that be?
At the point following,
In the back of the tower.
From the top of the tower to the ground. So from the top of the tower to the ground, that would be 55 meters. Okay? Do you see your right triangle that's formed?
yes.
Yes.
Because you're going straight down. From the top of the tower going straight down, that's going to be 55. They're not going to say, leaning, slanted, roughly. Okay? Now, at what angle is the tower leaning? Okay?
So we just put in the data symbol, right?
Now we're missing the theta. We're looking for an
And
angle.
you put it at the point of the tower.
And
The corner, the bottom corner.
Yeah.
the bottom corner. This is our theta. Okay? Because if we're trying to figure out how far it is leaning, it's not going to be this angle up here. That tells me nothing. Okay? But this angle is going to tell me that, okay, the tower is leaning at a particular degree. So, here's theta. And there's my labeling. Questions up here. Okay. Which trig ratio?
Opposite.
Opposite hypotenuse. So this is sine of what? What goes beside sine? Theta. That's my angle.
55 over 55.
Opposite over hypotenuse. Am I going to end up multiplying, dividing, taking the inverse? What am I going to do here?
Right.
Inverse.
Inverse is fine.
Because I'm looking for an angle. You always use inverse when you're looking for an angle. This is exactly what I'm going to type into my calculator, and we get
Small number, 1 step.
9.7.
79.7.
I didn't get that.
79.7?
Yes.
Okay.
Okay. Inverse.
There you go. Gotta make sure you do your inverse. Alright? And let's not forget our now, real quick.
How do you find an angle?
Hmm?
How do you find an angle? Is that what you're thinking?
No, not how to find the other angle. Let me see, make sure I word this correctly. It says, at what angle is the tower leaning? Okay?
So if the tower was originally straight up, right? And then it's, as it starts to lean, when they're talking about at what angle the tower is leaning, they're looking actually for this angle right here. Because think about it, if the tower was standing straight up, and then, over time it starts to lean, they're actually looking for that angle in which it has leaned.
Yeah.
So 90 minus the angle we just found will give us our actual answer to this problem, which is
10.3.
10.3.
Yeah.
Explain that again.
So this, the red vertical line basically represents the tower before it ever started leaning, right? But through time, it's going to continue to lean in one particular direction. And so the question is asking us at what angle is the tower leaning. We're actually looking for this red angle here. But in order to find it, we would have had to find that orange theta angle and then subtract it from 90 degrees, because if it was standing straight up, it would have created a 90-degree angle with the ground. So as the tower decides to lean, that is the angle that we're looking for versus the one on the inside. Okay? Look at your next example. I don't know what happened with the notes in the picture, but the picture didn't make it onto your notes, so go ahead and draw that in.
They have the same problem on every attack.
You're looking for the height of the tower. You're looking for the height of the tower. What do you think? See what we did in the beginning. How tall is the tower? That's what you're looking for. So,
Oh.
it's a right angle. So I can keep going. Let's see if I can do this with you. Nope. So you got a right angle. That 58 pertains to from the ground and up to this point. That's the 58. Any suggestions of what do you think we can do to find the height of the tower?
You gotta
Right.
You can find the length from the bottom to the top of the tower, like the actual bottom at 100 feet.
Okay,
And then you find the length of the cliff, because you just subtract.
there you go. Think you got anything to add on to that? So, Brian says that we can find that length from the top of the tower all the way down to that bottom part right there. Okay? We can find that length. Then we can find the length of the cliff. And then we can subtract the two. Okay? So we know the person standing 100 feet from the base of the cliff, so both of these are 100. What's the angle here from the bottom all the way to the top of the tower? What angle is that? It's the 58-degree angle. Brian says we should find this. What trig ratio are we going to use to find this? Tangent. So it's going to be tangent of 58 equals what over what? X over 100. Now to find x, am I going to multiply 100 by the tangent of 58, divide 100 by the tangent of 58, or take the inverse? Multiply. And I'll get my answer for how tall that length is. Okay, so this whole thing here is x. Now to find the height of my cliff, what angle is here? 30. And I'm looking for the height of my cliff. So this part here represents y. Please bear with me. Like I said, my board is not calibrated quite right. What am I going to use to find y? Tangent. So it's going to be tangent of 30 equals y over 100. Am I multiplying, dividing, or inverse? Multiplying. So once I figure out those two values, I'm going to end up subtracting them from each other to find out how tall my tower is. So go ahead and do that. Let's go nearest 10. What is it? 102.3? And this is in feet. Did anybody not get this? Are there any questions? Now, the last thing that we're going to talk about is solving right triangles. That basically means to find all the measures of all the sides and all the angles of the triangle. But you're not always going to be given that to you. So this very first example, which is probably going to be the only example we get to because we are running out of time, I want you to solve this triangle, round all side lengths to the nearest 10, and all angle measures to the nearest degree. Okay? And we are solving the triangle. So what piece of information do we not know?
Yeah.
We don't know
S.
angle S, we don't know angle R, or
Angle.
side SQ, which is labeled lowercase r. Does everybody see that, lowercase r? Okay, you use lowercase letters to represent sides, capital letters to represent angles. So this is what we need to find here. Which one do you think we should find first? By doing what? Say it again, Tiana. Pythagorean theorem. If you know two sides of a right triangle, you can use Pythagorean theorem to find the third. What is Pythagorean theorem? C squared, or the C is always the hypotenuse. So what's the hypotenuse in this picture?
10.
The 10. So I'm going to plug in 10 squared. Does it matter where the 3 goes?
Not really.
So I'm going to say 3 squared plus b squared.
And do 9 plus b squared equals 100. Subtract 9 over. Then you want to do the square root of whatever. Now you want to do the square root of that. That ends up being 1.
That ends up being r. And I am rounding this to the nearest 10, so I don't have to worry about simplifying. What is the square root of 91? Confirmation? Great. Is everyone okay? Which angle do you want to find next? S. So if we're looking for S, let's label our sides. Now I strongly suggest you use what's given to you. Because heaven forbid you find the wrong R or you round incorrectly and then you use that and it just throws you all off. Use the 3 that they give you. Use the 10 that they give you. 3, is that your opposite side or your adjacent? So what trig ratio am I using? Sine. So it's going to be sine of angle S equals opposite over hypotenuse. Am I multiplying, dividing, or taking the inverse? And you always take the inverse when you're looking for angles. Make sure you're in degree mode.
17.4.
Round to the nearest degree. 17.
Find the other angle, add one together to subtract from 180.
Exactly. How many degrees in a triangle? 180. So yes, you could do that. You could add the other two angles that you just found, so 90 and 17 to make 107, and then subtract that from 180 to find your last angle, which is
73.
And there you go. You could have also used trig as well, but you would end up getting the same answer. Questions?